Magnitude and direction of a vector given its graph. To get started with this, start off with the idea of a vector itself. A vector, we use the variable v as a generic vector, and we put this arrow, or just a hook, an arrow with half of an arrowhead, right? Instead of an entire arrow, we only put the top half of the arrowhead and we call it a hook. But it's just a decoration to indicate that this thing is not just a single number variable, but a ordered pair in a sense. So x comma y is a vector. You'll also see vectors sometimes indicated with a bar over them, with an underline, and in a lot of textbooks they use boldface characters. But a vector is a directed line segment beginning at the origin and ending at what we call its terminal point. So we use angle brackets, x and y, to indicate that the thing we're talking about is a vector pointing to the point in the coordinate plane, x comma y. So if we sketch out a set of coordinate axes here, and we find the particular point that we care about here, the terminal point, draw a line segment from the origin to that terminal point, and give it a direction. Sometimes you'll hear people refer to the head and tail of the vector. Again, that's not language that I'm going to use in this course, but because vectors are so prevalent in so many different circumstances, it's worth being familiar with. The magnitude of the vector is the length of this line segment. So if we have a vector drawn here, the magnitude, again, there are several different notations that we could use for magnitude. Our textbook doesn't actually use any notation at all, so I'll just mention that my personal favorite is to use an absolute value bar. So absolute value of vector is the length of the line segment. Again, using the generalized idea of absolute value of an integer, the distance from that integer to 0 on a number line, the absolute value of a vector is the distance from its terminal point to 0 in the coordinate plane. And then, in addition to magnitude, we also have to define a direction in which the vector is pointing. And there are, again, several standards. The one that probably makes the most sense based on what we've been doing is to measure the angle in standard position that the line segment makes with the positive x-axis. So with that, we have a magnitude and direction, which can also be enough to define a vector. As an example, let's take a look at a vector. Here's a nice vector drawn to a point. And let's say that this is the vector looks like I drew the vector 6, 3. To calculate the magnitude and direction of this vector, I'm going to start by modifying the picture ever so slightly, dropping a vertical line from the terminal point of the vector down to the x-axis, and recognizing that that makes a right triangle. And since this point is at 6, 3, I know that the height of that line is 3, and I know that the distance from the origin to that right angle is 6. And now my problem has turned into solve a right triangle. I know that I can use the Pythagorean theorem. My magnitude squared is equal to the length of one leg squared plus the length of the second leg squared. And I can punch those things into a calculator. 6 squared is 36, 3 squared is 9, and 36 plus 9 is 45. And then with that, I can get the magnitude itself by taking the square root. And depending on application, you might want to leave this as the magnitude is the square root of 45 if we want an exact value. Or if we want an approximate value, we can evaluate the square root of 45 and get something in the ballpark of 6.71. To find the direction here, again, looking at this right triangle, we have an angle. We know the length of the opposite side and the adjacent side. So that's going to give us tangent. Tangent of theta is 3/6. Which means that theta is the angle whose tangent is 3/6, which reduces to 1/2 if I can write. And again, if I'm happy with an approximate value, I grab out my calculator and get that this is something like 26.6 degrees, or if I want to be in radians, this is 0.464 radians. Pay attention to how it's asked for and make sure you're using the right angle units in the right situation. In general, this kind of calculation is going to be the thing that we are looking at. So for any vector given as xy, the magnitude of that vector is going to be the square root of x squared plus y squared, and the direction can be determined by the tangent of theta equals y/x. Right, those are formulas that are worth knowing.